Okay. Can so if everyone can hear me okay, I'm gonna go ahead and get started. So, good morning, guys. It's currently 9:30 p.m. here in LA, like always. Um, Hopefully you guys are having a good morning. We're gonna go ahead and get started. So, first on the agenda is checking yesterday's homework. So hopefully most of you guys submitted it, I saw. So yeah, I will pass it off to Aiden, who will be going over the homework.
Yeah, I will indeed be going over the homework. So I believe, yeah, there are multiple things that you had to do since last time, and we'll basically just be going over like some of them. Um, Also, just before I go over this, uh, make sure that you guys have submitted your homework in the turn-in sections if you guys haven't already. I'm pretty sure most of you have, so that's good. But if you guys haven't, then make sure that you guys do that. Um, yeah, let me share my screen. Um, Wait, what? Oh, sorry. Give me 1 second. Um, okay. Okay. So, last time you guys had to do exercises 1 through 8 from this string exercise, if I remember correctly. And yeah, we'll just be going over each of those. Um, yeah, let's start with 1A. So 1A is to create a string made of the first, middle, and last character in in whatever string that you give. So yeah, since it's a homework check, I'll just be going over each of them like right away. Um, okay. Okay. So first thing that we do, like always, um, we always need some sort of user input. So for this one, I'll just call it. I mean, they say string one, so I'll just use string one is equal to input, and then um, I'll just put like enter a string because it doesn't say to do anything specific. Um, and now what we want to do is we want to get the first, last, and middle string in that, well, in a different order, but still. Um, so yeah, what we would do with this, can go straight to a print statement because there's not really anything special we need to do for each of them. Um, but Yeah, you would start off with str1 and get the 0th position from there because if you remember, that's how you would get the first letter of a string. Um, and to get the middle letter of the string, you can do you'd have to do something a little interesting. You'd have to do str1, of course, and the number that goes in here is always going to be the length of our string divided by 2. Um, and that's because the middle letter is always going to be, well, that basically gets the middle of, or half of the length of the string, and that's where the middle letter is going to be. And then what we do for the last portion is to just do str1, is going to be to do str1 and then get the last letter. But of course, we don't know the length of the last letter. But if you remember, we can also use negative indexing to get to our last letter. So it would end up with something like you'd have -1 as your answer there. So if we were to run this, you'll see. I mean, what did they have here? They had James. So we'll write in James, and it should give us oh, okay. I see the problem. I think floor division would work for that. Okay, yeah. So the problem here was that we were getting a float number for this because like length of James would be 5. So 5 divided by 2 is 2.5, which you can't put as an index when you're calling a string or like getting a specific character from a string. So what we're doing instead is we're using floor division, which if you remember is 2 division symbols in order to make sure that our answer is an integer. And we can try it with like other ones. There is another example here, E3 power. So we can try that one as well. And you'll see we get the right one, EPR. Right there. Okay. We'll go over to the next one. We'll do exercise 1B next. And we'll take this out. Okay. Write a program to create a new string made of the 3 middle characters of an input string. So basically, kind of like the last one, we need to do something with the middle character. We also need the character before and after that, and then output that string. So we can start with the same thing. We can start with str1 is equal to input a string, and then and then what we can do after that. Actually, I won't go right into a print statement, and there's a reason for that. What we'll do instead first is get an index for where our middle is. So the middle, of course, if you remember, we'll do the same thing as last time, len of str, and then floor divided by 2. And then now what we can do with middle, since all we need to do is get the middle character -1 and the middle character, or like the character before and after the middle character, along with the middle character itself. And we have our index for the middle character. We can just do str1 middle -1, and then plus str1 middle, and then plus str1 middle +1. So now if we run this, they had 2 examples here. I'll just copy them. Oh, sorry, that's str1. Yeah, dip, which is what we wanted. And then if we do the same here, you'll see that it does the exact same thing, sun. Yeah, that was question 1B. Okay. Now we'll go to exercise 2. Given 2 strings S1 and S2, we want to create a new string by putting S3 in the middle, or putting S2 in the middle of S1. Um, sorry. And to do that, well, okay, first of all, we can take this away because we won't be needing that. Um, so yeah, what we can do for this one, um, sorry, give me 1 second. Okay, yeah, so what we do for this one is, again, we can have this middle section here just to figure out where in our index the middle is going to end up being. And we can, again, print. Okay, so, oh wait, sorry, we need two strings first. So I'll create another input for that. And yeah, this still stays the same because we need the middle of the first one, not the second one. And the way we'll print it is we'll print the first half of str1 first, then we'll print str2, and then we'll print the second half of str2, or sorry, str1. So we're going to start with str1. I mean, we don't have to put anything there. Blank to middle. Then we'll add str2, and then we'll add str1 again, but with middle to the end. And this should work. If we run this now, we'll just use the examples here again. Alt and Kelly. Alt and then Kelly. And then you get, I mean, it's right there, yeah. So yeah, that's how you would do exercise 2. Okay. Now we need to create a new string made of the first, middle, last letters of each input string. Given two strings, S1 and S2, write a program to return a new string made up of S1 and S2's first, middle, and last characters. I feel like it's a little broad, or it's a little didn't explain it well enough, but basically it's saying get the first letter of the first string, the first letter of the second string, the middle letter of the first string, the middle letter of the second string, and then the last letter of the first string, and the last letter of the second string. So yeah, we can do that. So yeah, we have two strings again, so we need to keep these two inputs. And now we're actually going to need the middle of both sections, so we'll just call it middle 1 and middle 2. And we'll do the exact same thing, but as string 2. Oops, 2, 2, 2. Okay. And now we have the two strings and the middle index of the two strings. So now we can go straight to printing. First, we want str1, the first character from str1. Then we want the first character from str2. And then we want the middle of str1. And remember, it's middle 1, not middle 2, because we have because middle 1 is the middle index for the first string. And then str2, middle, and this is going to be middle 2 because we're using str2. And then str1, -1 plus str2, -1. Yeah, let's use the ones that they had, America and Japan, and it prints out what we want. Okay. Yeah, if you guys want to take a better look at it. So yeah, that's exercise 3. Okay. So next one, we're doing exercise 4. Arrange string characters such that lowercase letters should come first. Given a string contains a combination of the lower and uppercase letters, write a program to arrange the characters of a string so that the lowercase letters come first. For this one, there's the way that we would do this one. I mean, you need to use a for loop. I'm not 100% sure if we've gone over that already, but I'm just going to use it in here because that's the only way that I can see that we can do this. But I mean, I really hope that we've done for loops so far. But yeah, we need to use a for loop for this specific problem. So, what we're going to do first, we went over lists last time, so we're going to use list here. Let's call them L1 or actually, let's call them lower and upper. Lower is going to contain all of the values with a lower case letter, and then upper is going to do all of them with an uppercase letter. So we're going to use a for loop, and then use for I in str1 because we're trying to iterate through every single value in str1 or every single letter in str1. And then what we're going to do is create an if statement where if str if I dot if I dot is lower, because if you remember, is dot is lower checks if a certain character is lower or is a lowercase letter or not. So if I dot is lower, then we're going to add that character to lower. So we're going to do lower dot append I. And then in any other case, which the only other possible case is an uppercase if we have only letters, we're going to lower dot append. Oh, I spelled append wrong here. Append. We're going to lower dot append I we're going to upper dot append I. And then what we're going to do after is just convert both lists into strings or into a string and then print that string. So let's call it like new str, and then this might not be something that we've done before, but we're going to basically do quotation marks dot join lower plus upper, and then we're going to print our new string. If we run this now, our string that we had, hi native, and it'll give us what we want. Lowercase first, and then uppercase. So yeah, that's exercise 4. Okay. Next one, we'll go to exercise 5. Count all letters, digits, and special symbols from a given string given that. So basically, given a specific string, we want to count the number of characters and the number of digits and the number of symbols. I think by characters it means letters, and I'm actually gonna write it that way. But yeah, I'm just gonna say letters instead of cars. So for this one, we're actually going to do something similar to this, and I'll actually keep this template because it's very similar to what we're about to do. Instead of using lower and upper, we're going to use letter, number, and symbol, and create a new list. And then we're going to keep this, and we're instead of asking if I is lower, we're going to say, as the hint says here, we're going to use the, is alpha and is digit. So we'll start with is alpha, and we'll append it to letter. If and then we make a new elif. In an elif I dot is digit. We're going to number dot append I. Otherwise, everything else is going to end up being a symbol, or at least for this situation. So we're going to append it to a symbol area. And instead of having to do all of this, we're just going to print. Well, okay, we're going to need to print 3 different things, I think. So we're going to say, oops, letters is, and then we add the length of each list, because that'll give us a number of each of the different types inside of, or the number of each case in, because that's how many are going to be in the list. So we'll do length of letter, and then we basically do the same thing, but for numbers and symbols. So number goes to numbers, and then we need to use symbols last, and then symbol. And I think actually we need to print this whole thing at the start, so I will do that as well. Print, and I'll change this to letters. Yeah, if we run this now, I'll just copy this. Where is it? Just here. And then this should, that's why. Okay, we just need to variable cast these. And then we'll just put that back in, and then you'll see that that's exactly what we have. We have letters is 8, numbers is 3, symbols is 4. Like we have 8, 3, and 4 here as well. Yeah, that's exercise number 5. Okay, exercise. Actually, I'll just show this real quick. Yeah. Okay. Exercise number 6, we want to create a mixed string using the following rules. Given 2 strings, S1 and S2, we want to write a program that creates a new string, S3, made of the first character of S1 and the last character of S2, and the second character of S1, second to last character of S2, and so on. And then all the leftover chars just get thrown in at the end. So, if you guys didn't get that, in this specific case, we're going to get A first because the first letter of S1, Z next because it's this last letter of S2, second letter of S1 is B, second to last letter of S2 is Y, and then same thing for C and X. And if there was anything else over here on like S2 or S1, they would just go at the end. So yeah, we can delete all of this because this is not necessary anymore. And we need to create a second input string. And then now we have S1 and S2. So the first thing we want to do, we're going to use the hint already, because it would be a lot easier if we were to just, like, what's it? If we were to just flip the first one, because then we'd be able to get the first letter of the first string, first letter of the second string, and so on. So what we can do is we can do str2 is equal to str -1, because what that will do is just flip the whole string. And now we have 2 strings where we're just getting the first one of the first one, second one of the second one, and so on. So we'll create another. Well, okay, this is one way to do it, but we can create another for loop. And what we can do in the for loop, we're going to use an in range, and I'm going to use min here. I think that's allowed right now. Which is basically yeah, for I in range, min length of str1 and the length of str2. And I mean, if you guys don't know what the min function does, it basically just gets the minimum of two values. Um, and yeah, there's probably another way to do this with some sort of if statement, but um, this is one other way to use it. Actually, I'll do it that way because it might be a little easier to understand. Um, so first thing we're going to do, if length of str1 is less than length of str2. Is that? I think I missed something. Length of str1, str2. Okay. Then what we'll do is we'll call minimum or min num, I guess, as the minimum length, as equal to str1. Or actually, we'll just make it length of str1. And then we'll do the same thing for the other way around. Elif len, actually, we'll just copy this. But then we'll flip this. Then we will make min num equal len of str2. And actually, we'll just make this greater than or less than or equal to, so that it also covers the time when they're equal. So for I in range min num, we're going to what's it? We're going to make an str. Actually, we should make an str3 before. Str3 is equal to nothing for now. And we make str equal, or sorry. Yeah, we're going to add str1, the first character, or actually, we'll just make the ith character, actually, that's better. And then we'll also add str2, the first character, or the ith character, because it's just going to go through each one of these through everything. And then now we have to account for having like stuff at the end. Or actually, I think. Oh, never mind. Actually, and we're also going to have. Oh, we should also put something here where it says where we know which one is going to be the smaller string, and which one's going to be the bigger string. So we're going to have min str as as str1, or actually, put that as a string, and it will do the same thing here. Min str is equal to str2. So now after we do this, if min str is equal to str1, then we know that str2 has some extra characters left. Actually, we're actually going to do this in that case. Sorry, I'm switching up a little, but this is better to do, I think. So yeah, if min str is str1, then we're going to add on the characters from str2 until the end. So we're going to do str3 plus equals str2 from min num to the end. And then we'll do the exact same thing if they are, if this is equal to str2, except we'll switch this to str1. And if there's any other situation, we'll just do nothing because we don't really need to do anything because it'll be covered by this. Um, and then at the end, we just have to print str3. So this should work. That's str2. And yeah, we get what we want. We get A, Z, B, Y, C, X. Yeah, that was a bit of a long one, but I hope that made sense. And yeah, I'll go. Oops, that's not the button. I'll go to the next problem. String characters balance test. Write a program to check if two strings are balanced. For example, strings S1 and S2 are balanced if all the characters in S1 are present in S2. The character's position doesn't matter. So, for example, in case 1, we have Y and N. And since both Y and N are in S2, the output is true. And that's because, and something to note is that you have to make sure that these are case sensitive. So if Y is uppercase, Y has to be uppercase in here. If this Y was lowercase, it would not count. And over here, Y and F is of course not in pi native in S2. So what we're going to have is false. So yeah, let's do that. I'm going to delete all of this. And of course, we do need two strings like usual. So we're going to have those two as inputs. So we have str1 and str2. Or actually, since they have them as S1 and S2, I'll also do that. So first thing we'll do is we'll go for I in S1. And then all we're going to do is check if each character of S1 is in S2. And if it is, then I will just keep. Well, okay. Well, you can create a true or false thing here. It's like is still in is equal to true, and if I not in S2, then we'll turn that into false. And then at the end, we just print is still in. So yeah, basically what we're doing here for every single character in S1, because if you remember, S1 can be really big. We're basically checking if the character is not in S2. And if it's not in S2, of course, we have to change it to false. So that's what we're doing here. Otherwise, if it is, we're not actually going to do anything. And since this is already at a true value, if all the characters in S1 are in S2, it's going to print true because this condition is never met. But if it's not in, this condition will be met and it'll be false. So if we run it, we're just going to copy these two strings, and we're gonna test both cases. So yeah. First one's true, and then we'll run it again for a second case. And then you'll see that it is false, just like we expected. So yeah, that is problem number 7, I think it was. Exercise number 7. And finally, for the last one, we're going to be doing exercise 8. Find all occurrences of a substring in a given string by ignoring the case. So write a program to find all occurrences of USA in a given string, ignoring the case. So yeah, well, okay, it's kind of weird wording, but we're basically going to completely ignore uppercase, lowercase, and we're just going to, if it says USA, then we're just going to like count it. So yeah, we'll take away this, and we only need one input for this, so we're only going to have S1. And then yeah, for this one, first thing that we'll do is yeah, we'll make S1 dot lower, and we'll just use like we'll call it like new str is S1 dot lower, because of course we want it to be case insensitive. So both of these two should count, and the way we're going to do that is make everything in S1 lower, such that if S1 has an uppercase USA, it's not going to be any different from a lowercase USA. And what we're going to do after this, of course, we need to check for every single value of USA. So we're going to just call it count, I guess, is going to be equal to new string dot count, because if you remember, that's what this function is here in the hint. And then we're going to count for USA. And we're using the lowercase version because remember, everything in S1 is lowercase right now. So if we were to do something like, if we were to use uppercase, there will be none of them in the first case. So we're going to be using lowercase. If we run this now, and then we take this, that should give us, oh, sorry, I forgot to print it. Print count. Oops. Yeah, if we run it now, you'll see that it prints out 2 like we wanted. And if we were to run something slightly different, like USA, UAS, USA, something like that, it'll still print out however many USAs there are. Yeah, and that is exercise 8. That's all the exercise that we're going over in the homework check today. And yeah, now I'll pass it off to Julia to talk about tuples.
Okay, so I'll be talking about tuples today. Yeah, get that up. Okay, can everyone see my screen? Okay, great. So to begin, Python tuples are very much similar to Python lists, which we went over yesterday, but it's one of the main differences is that it's unchangeable, and I'll be talking about that a little bit more further on. But as you can see, tuples, unlike lists, start with soft brackets instead of hard brackets. So around apple, banana, and cherry, you have soft brackets. And if you print it, as you can see, if you print and run it, you can see how it prints exactly the same with soft brackets around the 3 items. Yeah, so these are tuples. And so these are the 3 characteristics of a tuple. First of all, they are ordered, which means that all the items have a definite order and that doesn't change. So if you see this order, this apple is going to stay in first place and it's not going to go to fifth place. The tuples are also unchangeable, which makes them different from lists. So unlike lists, you can't easily replace apple for pear. Instead, it stays apple and it requires a bit more effort to change an item to something else. And tuples, like lists, allow duplicates, which means that, as you can see here, even though there are 2 apples and 2 cherries, the tuple works perfectly fine and doesn't have any issues. Okay, so similar to the list function, you can find the length of a tuple using the len function. So if you try it out, you can see right here that we created a tuple, and then by doing print len and then the tuple's name, you got 3 because there's 3 items inside the tuple. And when you create a tuple with just 1 item, you have to be sure to add a comma after that singular item, because otherwise, if you look here, otherwise, if you don't add a comma after that singular item, it prints the type of that item instead of printing the type tuple. So you can see right here how it's different and why you need to add that comma after the 1 item. Additionally, tuples can be of any data type. You can see right here that this first tuple was created with with strings inside each, with strings for every item. In the second tuple, we have integers, and in this third, we have Boolean. So any Boolean can be inside here. They can also have different items. You can see right here how there's a mix of strings, of integers, and Booleans. It doesn't matter if they're all together like this. And as we saw above, to get the type of a tuple, you use the word type. And if you see right here, you can see right here that when you use print type my tuple, it's printed class tuple. So when you create a tuple, while up here you can also just use the soft brackets between each item, between surrounding all of the items. Another way of creating a tuple is to use the word tuple, then soft brackets, insert in your tuples items, and then another soft bracket to close it. So these are just 2 ways to create a tuple. Both of them work. So yeah, that was the start of tuples. Now let's go into how to access specific items or multiple items of tuples. This should be pretty familiar as we went over this yesterday. It's a pretty similar concept. So just like last time, with lists for tuples, you have the tuple, you have and you have hard brackets, the square brackets, and inside you have an index. With the knowledge of like what we went over yesterday with lists, can anyone guess what would be printed out with this index 1? It's a pretty similar concept. Well, with as with most things in Python, tuples are also begin with a correct. So since like Python, most things in Python, you use a index system starting with 0. So since apple would be 0 and banana would be 1, this would print banana because that's what's in the first index. And just like before, you can also use negative indexing to go from the start to the end. So it allows you to go backwards. So you can see right here, this -1 refers to the last item, which would be cherry. And if you put -2 here, it would be the second to last item, which would print banana. So you can use negative indexing and positive indexing, just whatever suits your interest. And again, with tuples, just like lists, you can have a range of indexes. So in order to print multiple items out of a tuple, you can do the first index, which is where you'll be starting, and another index, first number, a colon, and a second number, which is where you'll be stopping at but not including. So it's the first number is included and the second number is excluded. So if we consider that apple starts with index 0, can anyone guess what would be printed with this range of indexes? And yeah. Yeah, and so it would definitely begin at cherry because that's where index 2 is, 0, 1, and 2. And it would stop at kiwi because melon is at index 5, but we don't include that, so it goes from cherry to kiwi. Yeah, good job. So that's how you'd get a range of indexes. So that's how you pull out a section of the tuple from the entire tuple. And like before, if you leave out the first number out of this range of items, Python automatically assumes that you'll begin at the first index and then go to the fourth index but not include it. So you can see right here that it would start at apple, banana, cherry, orange, and and stop before kiwi, so it go do these 4. If you leave out the second number, like before, you just start at index 2, which would be cherry right here, and you go immediately to the end. So it would be from cherry to mango, all of these items. And the same thing applies to negative indexes like before. This would begin at -4, which would be orange to and it will go to -1 but stop before it, so it'd be these 3 items, as you can see from here: orange, kiwi, and melon. So that was pretty much the same as list because they're pretty similar, just the difference is that a tuple is unchangeable. And like before, if you want to check if a item is in a list, you can use the in function methods keyword. So if you want to check if the item apple is in a tuple, you can do if apple in tuple print yes, and this would print this statement right here because the this item apple is in the tuple. Okay, so as I mentioned previously, the tuples are unchangeable, but they're not forever stuck like that way. There's still ways to change them. It's just a little harder. So you can see right here that while tuples themselves are unchangeable, a way to work around this is to convert the tuple x into a list. So you can see, right, it'd be converted into a list right here. And then you can change the item of that list and convert the list back into a tuple. So it's kind of a workaround, but it's a way of changing an unchangeable tuple. So if we print it and we try it, you can see right here that originally it was apple, banana, cherry. We turned this into a list, and we changed the item in index 1, which is banana, into kiwi. And once we turn it back into tuple and print it, we can see right here that we changed the item in index 1. Okay. You can also, since tuples are unchangeable or immutable, as they say, they don't have like an append function like the list does. However, there are still ways to work around this. Like before, like we just did, you can convert it into a list. So you can turn this tuple, you can turn it into a list right here. You can use the append function that a list uses, and then convert it back into a tuple and technically add another item on. So you can see right here how we started out with apple, banana, cherry, and you appended orange on, and we got to this 4-item tuple at the end. Another way of adding new items to a tuple is adding a tuple to a tuple. So while you can't add individual items on, you can join two tuples together. So you can see this happening right here. We have the original tuple right here, and we create another tuple with one item, orange. And you can see right here that the comma needs to be included to make this a tuple, otherwise it would just be a string. So onto the first tuple, we add the second tuple, and if we print this out, we can see how orange was added onto this original tuple. And this is just another way to add an extra item in a tuple. Okay. Okay. And now removing items is a bit harder. So again, it's hard because you're not supposed to change a tuple. However, there are workarounds, and like before, one way to remove items is to convert it into a list. So you can see right here, we have a tuple, we turn it into a list, and we remove the item we want to remove. In this case, it's apple, and then we turn the list back into a tuple. So if you can see right here, we started out with apple, banana, cherry, and we converted the tuple. We converted the tuple into a list, removed the item apple, and turned it back into tuple. And printing it out, we get just banana and cherry because we removed apple. And another way to remove items out of a tuple is just deleting the tuple completely, which I don't know, like it's not as effective or as specific as converting it into a list and removing one item, but it's a way of deleting a tuple. So if we run this, you can see right here we deleted the tuple with a del keyword, and if we print it, the tuple no longer exists. So that's just another way of removing a tuple. Okay. So one thing you can do to a tuple is called unpacking it. So when we insert items into a tuple like this, we have apple, banana, and cherry, 3 strings added into a tuple. That's called packing a tuple. However, when you work with tuples, you can also do something called unpacking a tuple. This means that we have the tuple and we now create 3 different variables from that tuple. So you can see right here in parentheses, we put 3 variable names in the parentheses and equaled it to the tuple. And if we run this, we can see right here that each item corresponded into a variable. So green was equal to apple, yellow was equal to banana, and red was equal to cherry. So each of these individual items was inserted into the variables right here. So this is how you unpack a tuple. And another thing you can do is use an asterisk while you're unpacking a tuple. So perhaps, so if you use an asterisk, what it does is that if you have extra items that like, okay, if you have more items and you have variables right here, that means that the remaining items are going to be inserted into a list in this variable. So it becomes clear if I actually print this out. And you can see right here that the first variable, green, was assigned to apple, the first item. Yellow got the value of banana, and red, because it has an asterisk in front of it, got all the remaining items of cherry, strawberry, and raspberry, but in a list form. So you can see right here how it kind of corresponded with each item value. And the asterisk doesn't just need to go in the end. The asterisk can also go in the middle. And what this means is that green will correspond to the first item and red will correspond to the last item. But however, the asterisk value in the middle gets all of the remaining items that haven't been already assigned. So if we run through this, we can see how green was apple, red was cherry, which is at the end, and tropic got mango, papaya, and pineapple, which were all in the middle. And you can see right here with these hard brackets that tropic became a list. Okay, so looping through a tuple. Just like with a list, you can loop through a tuple using a for loop. So for x in this tuple, you print x. And if we run through it, we can see how for each item we printed every item of the list because we went through this for loop. That's one way of looping through tuples. Another way of looping through tuples is using a for I in range. So you can see right here that we started with the tuple, this tuple, and for I in the range of the length of this tuple, you're printing each item of the tuple. So let's try it out. And you can see right here that for each from 0 to from 0, then 1, then 2, it printed out each item of this list using the for I in range method. So that's just another way of printing out looping through a tuple. And lastly, you can use a while loop to loop through a tuple. So you start with a tuple and you have the variable I, and while I is less than the length of this tuple, we're going to keep on printing the index I of the tuple. And of course, since you don't want the while loop to repeat forever and never end, you always have to increase the value of I by 1 at the end of the after each repetition in order to get something like this, where each value is printed out properly and one at a time. So that's the third way of looping through a tuple. Okay, and you can also join two tuples together. So we saw this previously where like joining two tuples was a way of adding an extra, appending new items into a tuple. This is the same concept. You can add two tuples together to create one tuple. So if we try it out, you can see right here that tuple A, which is ABC, was added on to tuple 2, which is 1, 2, 3. So you can see right here how they all became one tuple with the use of the addition sign right here. Okay, and you can also multiply tuples by a number. And if you try it out, you can see right here that multiplying a tuple by a number such as 2 results in the tuple being repeated twice. So you can see right here that we have apple, banana, cherry, and then again we have apple, banana, cherry because this tuple was multiplied by 2. So that's just a way of multiplying tuples. Okay, and these are just a few of the tuple methods. Count allows you to, so if you do the tuple name dot count, and then an item is that to count how many of that items of that how many times that item appeared in the tuple. And index, and if you put an item inside these parentheses, allows you to check the first occurrence of that item in the tuple. So let's say we have a tuple. The first item is apple, and if you do tuple.index apple, it would return 0 because apple is at index 0. And finally, here are some exercises for tuples. Let's go here. So just a quick 4 exercises. Does anyone know the answer to this? Use the correct syntax to print the first item in the fruits tuple. So we would use indexes. Yeah, good job. So it'd be fruits, hard brackets, and 0 because someone answer. Because the tuple begins with index 0. Nice. Okay. So second question. What is the way to print the number of items in the fruits tuple? Yeah, that's great. So we'd be using the len function, which gives the length of a tuple. So it'd be len fruits, and if we submit it, yeah, that was great. Okay. This time we're trying to use negative indexing to print the last item in the tuple. What would I use? Yeah, that's perfect. So we do fruits, hard brackets, and inside these brackets we put a -1 because that allows us to go backwards into the tuple. Sounds great, and that's clearly correct. Okay, last exercise. In order to get a range of indexes from the 3rd, 4th, and 5th item in the tuple, what numbers and symbols would you put in here? Yeah, that sounds great. So it'd be 2 colon and 5 because cherry is at item 2 and 3, 4, and since melon is at 5, we put a number 5 here because it excludes melon. And if we check that, yeah, we got it correct. So those were tuples. I hope I explained them correctly. And if you guys have any questions, feel free to ask. So I'll be stopping my share and yeah.
Okay. So the next thing on our agenda is going to be sets, which is going to be taught by me. So I'm just going to go ahead and share my screen now. Okay. So sets are a lot like other iterables that we went over, like the lists and tuples, but obviously they have their distinct qualities, right? So basically, the qualities of a set are that it's unchangeable, unordered, and unindexed, right? So basically, unordered and unindexed, you guys understand, right? It's this pretty much means the same thing. It does not have an order, which means it doesn't have indexes. And then unchangeable means that it's going to basically you cannot delete or add values, but you can remove values and add new ones as well. Or sorry, you can so sorry, I meant the opposite. So the items in a set are not changeable, right? You can't change like banana to banana with two ends, but you can remove items and you can add items. Okay. So once you add something, it can't be changed. Okay. So to make a set, right, it's pretty much how you make any iterable, except we're going to use curly brackets instead of something like brackets and parentheses. Okay. And sets are unordered, right? So you can't really be sure of the order in which items will appear. So if you're going to use a set, you have to make sure that whatever's inside of the set, the order does not matter. Okay. So yeah, unordered, unchangeable, right? We went over this, and then duplicates are not allowed in sets. So basically, duplicate values are going to be ignored. If we look at this example, here we have a set that's named this set, and it has apple, banana, cherry, and apple again in it, right? But after we make it, if we try to print it out, then it's just gonna have banana, cherry, apple, right? Notice how this one is not included, right? And this is just because it doesn't allow duplicates. Okay, so it's just gonna because we already have apple in it, it's gonna ignore this. Uh, okay, so an important thing to note is that the values of true and one are technically considered to be the same thing in a set, and they're treated as duplicates actually. So, for example, here we have a set that has apple, banana, cherry, true, one, and two, right? And remember how I said true and one are duplicates, right? So, whichever one comes first is going to be the one that's going to be kept. So, yeah, it's priority of order. So, basically, if you have true first, it's going to keep the true. But if we swap these two, so if I say one comma true, then what's going to happen is once it runs, as you can see, it keeps the one because the one comes in the beginning. Okay. And notice how the order here is completely different from the order that we gave it because sets are unordered, right? So they don't have a defined order. And another thing to note is that false and zero are also considered to be same values in sets. You can think of it as like a boolean, right? Zero, false, true, one, right? You can think of it like kind of like you know off on it. Sorry, I meant on and off, right? Like a light switch, right? So zero meaning off, and then one meaning on. And so the same thing applies for false and zero. So in this example, because false comes first, false is going to be kept, while zero is going to be simply ignored because there's the same duplicate value and we have priority of order. Okay. Okay. In order to get the length of a set, we use the len function, like any other iterable or string, right? So if I print out len of this set, it's going to print out 3 because we have 3 items here. Okay. So for data types, like other iterables, right? So like lists, sets can have multiple different data types in one set. So you can have strings in it, you can have ints, you can have booleans, right? These are all valid. Or you can have different types of variables in one set, in one big set, right? So that's pretty interesting. Basically, it doesn't really matter what you put into a set as long as it's some form of variable, right? And type, right? So if you run the type command on a set, it's going to return class of sets, right? Um, so as you can see, it does that just right here. And this is because, this is declared as a set. So it's going to return the type of whatever is in the input. So that's pretty simple. And if we don't want to use the curly brackets, then what we can do is we can just use the set constructor. So this is literally the same thing as making a set in the traditional way, right? Using curly brackets, except it's really just using a constructor, which is the set constructor, right, to make a set. So pretty much the same thing, right? Um, but you have to notice that it has double round brackets. So whenever you use the constructor, you have to use 2 in the beginning and 2 in the end. And remember that sets are unordered, so the result is going to display the items in a random order. Right? So here we have apple, banana, cherry. Here it says cherry, banana, apple. Um, and yeah, it's absolutely random. Um, so you're not going to know which order it is because because sets are unordered. Okay. And so yeah, that's basically the overview of sets. To access set items, you're going to have to use a for loop. Okay. So as we went over with some other iterables, right? You can use a for loop, which basically says that for each value in this set, right, which is the set we have here, we're going to set each value equal to x temporarily, and so x is going to be equal to apple here, and then it prints out x, which is apple, and then it goes through another iteration, and now it's equal to banana, and it prints out banana, and now it goes through another iteration, and now it's equal to cherry, and then it prints out cherry, right? So at some point, x is going to be equal to all of these, just in order, okay? And as you can see here, it prints them out in order. Okay. Um, and then to check if something is in sets, if it's present, right? We just do the in command, right? So if we want to check if banana is in the set, we do print in banana in this set, and it's gonna print true because banana is in this set. That's a true statement. Okay, so we can see that right here. Okay, to add items to a set, what we can use the add method. So here we have our oh, my mic is a bit low. Okay. Okay, let me try to increase that in settings really quickly. Um, Unfortunately, it's not letting me increase my microphone volume, but hopefully, I put it a bit closer to my mic, so hopefully it's a little louder now. But yeah, please let me know if you guys can't hear me. Okay. Okay, so continuing on. So in order to add an item to a set, we use the add method. So in order to use the add method, we're going to call the name of the set, then dot add, and then we're going to add whatever we want in the input. Okay, so this is going to add it to the end. It's just going to stick it right on here. So when we print out this set after adding orange, it's just gonna add it in the set. So so that was my mistake. So if it was ordered, it would add it to the very end. But remember, sets are not ordered; they're unordered. So that means it's just gonna add it into the set. We don't know where it's gonna go because it doesn't have an order. Okay. Okay. It looks like you guys can hear me now. Okay. Sounds good. Thank you guys for the feedback. Okay. And then we can also add sets into other sets, right? So here's an example where we have two sets, this set and tropical. Okay. So if we do, in order to use the update method, we call the name of a set dot update, and then we put in the input section, we put the name of another set. Okay. So what this will do is it will add all of these elements into the current set that we're working with. Okay. And remember, because it doesn't have an order, we don't know where exactly it's going to go. We just know that it's going to go inside of this set. Okay. So it's just adding everything in here into this one. So this is going to be the one that's being updated. This one is the one that's being actually that's worded kind of weird. So this one is basically going to be the one that has all the values. This one's going to be the one that's donating its values, right? So this one is doing the donating to this one, and this one is getting all of the donations, I guess you can say. Okay. And so yeah, that's the update method. And you can also use the update method to add any type of iterable, right? So you can add tuples, you can add lists, dictionaries, right? So here we're adding my list, right, which is a list, into this set, which is a set, right? And so when we do this set dot update my list, it's going to add all the values in my list into this set. Okay. So we're not adding the fact that it's a list. We're only adding the values inside of it. Okay. So the values inside of my list are just going to be put into this set somewhere. And then as you can see, once we print it out, we have our set, which has been updated. Okay, to remove an item from the sets, what we can use is one of these two, which is the remove or discard method. So for the remove method, um, we can just call the name of this set and then do dot remove. And then in the parameters, we put whatever we want to remove. So in this case, we want to remove banana. So banana will just be deleted from this set. And after removing it, it will just hold apple and cherry. Okay. So if we click on try this for ourselves, as you can see, after we print it out, it only has apple and cherry. And it's important to remember that if the item to remove does not exist, the remove method will call an error. Okay, so for example, if we try to remove if we try to remove orange, right? Orange is not in this set, so that means that it's going to call an error. And we can also do the discard method, right? So basically, discard is almost the same thing as remove. The one of the only differences is that if the item to remove does not exist, discard will not raise an error. So, for example, like if you're trying to brute force delete everything, let's say that you want to delete any number. Let's say that you have a set, and in that set you have all numbers from 1 through 500. Okay. So let's say that you have a set and you have numbers that are scattered in the range of 1 through 500. Okay, so you might have like 1, you might have 7, you might not have 10, but you might have like 13, right? And then let's say that you want to remove all the numbers from 250 to 500, that range in the set. Then you would use something like discard and just check for every single number between 200, 250 and 500, and it'll try to delete it. If it exists, it will delete it. If it doesn't exist, it won't do anything, right? So that's the nice thing about discard. You can also use pop to remove an item, but it's going to remove a random item, so you're not going to be sure of what's being removed, right? So because it's unordered. So the return value of the pop method is the removed item. So if we test this out, right, um, we have a set right here, our example we've been using this whole time, and then we pop an item, and then you know how because it returns the popped item, it's going to be set equal to x, and so now x is going to hold whichever item is removed. And then now we're going to print out the removed item and print out the set after the removal. So once we run this code, we removed cherry this time, but if we run it again, it's gonna okay, so it removed cherry again, but now it removes apple, right? So remember that it's gonna remove a random item. Okay. So yeah, that just says what I just said. And you can also use the clear method, right? We've already gone over this. The clear method just deletes every value without deleting the actual set itself. But on the other hand, the del keyword is going to delete the set entirely. So the set is no longer going to exist after this line. And then we can test that out. So as you can see, when we try to print out this set, it's going to give you an error because after this line, this set doesn't exist, right? Okay, moving forward. Yeah, for loops. So as I explained earlier, in order to loop through a set, you're just going to do a for loop, a classic for loop, for x in this set, print x, or do whatever with x, right? And x is going to be, basically this for loop is going to iterate through this set, and iterating is just going through each element in a set or in any iterable in order, right? So although this doesn't have order, right? So it's just gonna go through the items at random, and it's just going to print each item, right? So that's how to access set items with a for loop. And joining two sets. So there are a lot of ways to join two sets. Here's one of them. It's the union method. Okay, so union, basically what it does is you have two sets here, right? A, B, C, and 1, 2, 3. And then now you make a third set. Okay, so set 3 is going to be equal to set 1 dot union set 2. And so if we go ahead and look at what this outputs, notice how it's going to have all the elements of the first or the first two sets, right? So basically, it just joins them together, and it sets it equal to set 3. Okay. So that's pretty neat because instead of doing something like set 1 dot update set 2 and then set 3 equals a copy of set 1, you can just do it directly like this. Okay. So yeah, that's the union method. It combines two sets, and you can set it equal to a third one to make the third one equal to the combination of the first two. Um, the update method, right? So we went over this, but the update method basically will just join the second set into the first one, right? So now set 1 is going to have all of sets 1 values and all of set two's values. So you can see that demonstrated here after we print it out. Okay, and it's also really important to understand that the union and updates methods will exclude any duplicate items. So because sets do not allow duplicate items, it's just gonna ignore them. But if we basically what this means is that if we have the same value in two of the sets, so if we have A in this set and A in this set, it's going to ignore them. But if we only want to keep the duplicates, right, then we use something called intersection update. The reason why it's called intersection update is because it's just saying like where x and y intersect, right? So that means like where they have the same values. So like in a graph, right, when two lines intersect, they have the same value, right? Just like that. Um, in the intersection update method, um, an easy way to remember it is that it keeps the values that intersect between two sets. Okay. So for example, if we want to keep the values that repeat or are existent in both x and y, the only value that exists in x and y is apple. So we're going to keep apple. And the way that the intersection method works is you're going to choose which one to store all of the duplicates in, which is in this case going to be x. And x is just going to basically this method is just going to store the duplicate values in the set, which is x. And then, yeah, you can see that happening here. Okay. So the intersection method will return a new set. So you can also set it equal to a new set, right? And then you can print that out. So yeah, as you can see here, now Z has all the duplicates between the two. And if we just print out X and Y after on this example, then as you can see, these two remain intact, okay? Nothing is changed in these two. It's but now we have a set that just shows whichever whichever values they have in common using the intersection method, right? So that's the difference between intersection update and intersection. Intersection update is going to put all of this into this, right? It's not going to return a new set, but this one is going to return a new set, okay? And it's not going to change these two. Okay, keep all but not the duplicates. So this is the symmetric difference update, right? So you might think, hey, isn't this the same thing as just the regular update? But no. If you think about it, right, the regular update method is going to keep one of the duplicates, right? But this one is just if it has two values or if it has a value that repeats in both sets, it's going to just not keep any of them. Okay. So that would be the symmetric difference update. And you can think, I know this is like a really long word. It's kind of weird why Python made this so long, but you can think of it as symmetric difference means like it's kind of counterintuitive because symmetric and difference are opposites. But symmetric means that like x and y have symmetry because they have two values, right? So you can kind of remember it that way, I guess. Yeah, it's good to think of just silly little things like that to help you remember method names because there's a lot of methods and sometimes it gets a little hard to remember them. So this symmetric difference update will basically just put all the values of y that do not it'll basically put all the values of y into x and it will not keep any of the duplicates, right? So Google, Banana, Microsoft, Cherry, these are all unique to their own sets. Okay. All right. So the next method or the next thing is symmetric difference. So notice how the same thing goes on for intersection update and intersection and symmetric difference update and symmetric difference. It's doing the same thing, just it's the only thing that's different is whether it's keeping the duplicates or not. Okay. So the format is the same. So the symmetric difference update will just return a new set that contains the elements that are not present in both sets. Okay, so um, basically Z will be equal to Google, Banana, Microsoft, and Cherry. These are elements that are only inside of their respective sets, right? No duplicates. And remember that X and Y will still be intact after this. They will not have changed. And true and one are also considered the same value. So that's something that's important to note. If we run the symmetric difference on this, as we can see, it's not going to keep either one of them because they're technically the same thing in Python's eyes. Okay. So yeah, we're not going to keep either one of them, as you can see here. Okay, set methods. So add, right? If you do like this set dot add, it adds whatever you have in the parentheses to the set. This set dot clear removes all the elements from the set, but remember it does not delete the set itself. The set still exists after you clear it. Set.copy returns a copy of the set. So if you have like if you want to copy a set into another one, then you're gonna have to make it so that like this second set equals first set dot copy. Okay. Difference. It returns a set that basically has the difference between two or more sets. So just remember that when we run the difference, right? Because here we have Apple as the same value, right? It's going to return, uh, one sec. Yeah, so it's going to return cherry and banana because of that. Okay. You don't have to worry about this one too much, in my opinion. Me personally, I don't use this one too often. But yeah, moving forward, um, the difference updates method removes items in the sets that are also included in another set, okay? Another specified set. So it's going to have a parameter, right? And another set is going to go into that parameter, okay? So it removes the items that exist in both sets. It removes the duplicates, right? So since Apple exists and exists, it's going to just in the end it's going to just return cherry banana. Okay. All right. And so the next method is the discard method. Okay. Discard just removes a specific item, right? But remember that it doesn't return an error if the item doesn't exist. The intersection is going to return a set that has the intersection of two other sets. Um, this has a really they word some of these methods really weird. So if you guys have any questions, right, feel free to put them in the Q&A. But yeah, remember the intersection will return a set that has the duplicates. So it's going to have apple here because the apple is the only thing that is the same in both sets. And intersection updates does the same thing, but returns it to an um, existing set, right? Instead of returning a new set. And then is this joint is subset. A lot of these methods are just booleans. So basically, this is just returning. They're all returning booleans, just asking, is this a intersection? Do these two sets have an intersection? Yes or no? Do these two sets does that contain another set? Yes or no? Right? Pretty simple stuff by the definition. Um, and then pop removes a random element, right? Removes a specified element. Symmetric difference update basically symmetric difference returns a new set with the symmetric differences, and symmetric difference update, it will insert the symmetric differences from one set to another. So remember that symmetric difference is basically just returns. Um, sorry. So just remember that symmetric difference, right? In this case, since we have apple, banana, and cherry here, and we have Google, Microsoft, and Apple here, remember that it's going to return everything but the duplicates, right? So we have Google, Microsoft, banana, cherry, and those are here, right? So no Apple because it appears in both sets. And finally, we have union, right, which is returns a set containing the union of two sets, right? So contains a set which combines the two, right? And we have updates, which updates. It's basically like union, but it just updates one set. Okay, so it adds a bunch. It adds one set's values to another, or one iterable's values to another's um, iterable, because the update method is kind of universal, right? But that is all for methods. So now we're going to move on to exercises, right? We're going to go ahead and get started with this one. So how do we check if apple is in the fruits set? Can someone give me an answer? Yeah, that's correct, Jesse. It's in. Shamim, thank you. Okay. And then use the add method to add orange to the fruits um, set. Jesse, not exactly. Shamim, yeah, that's correct. It will be fruits dot add orange. So remember that whatever you're adding goes in the parameters. Okay. And use the correct method to add multiple items, more fruits to the fruits set. So we just went over this. I did say that the method is universal, so that might give you a hint. And remember, we're adding more fruits to fruits. Um, thank you, Shamim. Thank you. Yeah. So Shamim, thank you. That's how you update it, right? So remember, so I know this is a little confusing, but we have fruits and we have more fruits, and we're trying to add more fruits into fruits. So we would say fruits dot update, and then in the parameters we would put more fruits. Okay. And yeah. So for the next exercise, we are um, using the remove method to remove a banana from the fruit set. So how would we do that? And if you guys have any questions on the exercises, right, don't forget that you guys can always ask, and don't hesitate. So that one of the teachers can get back to you with an answer before class ends. And yeah, that is correct. Thank you, Shamim. Thank you, Jesse and Shadrach. Yeah, I think everyone got this one right. So good job, guys. Alicia, that does work, but remember we want to use the remove method. Yeah, so the discard is next. So Alicia kind of gave the answer to this one with so thank you, Alicia. But yeah, we use in order to use the discard method to remove banana from the fruits set, we would do fruits dot discard banana. Okay. So yeah, that's how we use the discard method to remove banana from the fruit set, and that exercise is correct. So now that's pretty much all I have for you guys for sets. Um, so the next thing on the agenda is going to be dictionaries with Aiden. So I'm gonna hand it off to Aiden now.
Yeah, I'll be doing dictionaries. So let me share my screen. Okay, so yeah, we're going to go over dictionaries for this next part. Um, and yeah, this is kind of what a dictionary looks like. A dictionary is used often to um, have multiple, um, to like have a value that's attributed to a certain like indicator, if that makes sense. So, for example, if we wanted to get this word, if we wanted to get Ford, then we would need to use this brand in what we call a key value pair. So this is a key, this is a value. Um, Maybe it says something similar here, but like um, when the reason why it's called key value pairs, if you think of it kind of like a door or a lock, in order to access the value inside of like say like a chest, a treasure chest, you would need a key to open the lock. So it's kind of you can think of it kind of like that. Um, so yeah, first let's show how to print a dictionary itself. Um, okay, so something that you'll see very often, or actually not very often, is really only this specific exercise. But um, when they're always going to, at least for W3 schools, the thing that we're using to teach this, they're going to be using or they're going to be showing dictionaries like this, where they do each key value pair on separate lines. But in Python, they're more thought of all as one line. And this is also a valid way of writing this. If we were to write all of this on one separate line, or like one single line, then it would also be a dictionary. It's just that this is a lot more clean, and this is the way that the thing that we're using to teach is using it as. So when you actually print it, it's going to show up all in one line, but just know that these two are basically exact same thing. So yeah, to print dictionaries, you just have to print the name of dictionary, just like every other area that we've gone over. Um, and yeah, just throw that inside the print statement. Um, Next, we'll be going over the dictionary items. Like I said, the dictionary items are in a key value pair. So um, it's going to be like a key and a value. So if you want to access the value, you're going to want to use the key. And like a list or a tuple, you're going to want to specify the specific value that you want by using square brackets, or like the name followed by the square brackets. But instead of writing a number in here, you're going to be using a key, or more specifically, whatever key that you want to get the value that you want. So if we wanted to get Ford, then we would have to do distinct.brand, or distinct and then brand. Let's say we wanted to get Mustang. So we would change that to model. And if we run it, you'll see that it prints out Mustang. And if we wanted year, then we could change it to year. And then once we run it, you'll see that it prints out 1964. So yeah, once if you want to get a specific value from a dictionary, you just do the name with square brackets and then inside the name of the key that value is attributed to. Also, make sure that if the key is a string, which in most cases it will be, make sure that you have the quotation marks around it. Okay. So even though dictionaries are slightly different from how lists, tuples, and sets work, there's still the ordered, unordered, changeable, and duplicate stuff. In this case, Python considers dictionaries ordered. I know it says like as of Python version 3.7 and all that. For our purposes, dictionaries are considered ordered. They're also changeable, and duplicates are not allowed um, in dictionaries. And that's to say, uh, like you can't have the same key multiple times. Okay, well you can have the same key multiple times, but if you were to write the same key 2 times, like this shows, you'll see that it just overwrites it. So even though we have year equals to 1964 here, since we have another year that's equal to a different number, in this case 2020, when we print out the dictionary, it'll say that the year is 2020, not 1964. That's because when we called the key again, we called it for a different number, which overwrote the original one that we had. You can kind of think of it as like redefining a variable. But yeah, you can't have multiple keys with different values. So if you want to get the length of a dictionary, it's really similar to how you would get it for other like arrays. So, oh, that's the right one. So you just use the len function again, and the way the len function works for dictionaries is it only counts the number of keys. It doesn't count the values as well. So in this case, it would be considered 1, 2, 3. And the reason why it has 3 and not 4 in this case is because, again, you can't really have duplicates, or like it doesn't really count as a separate key. So these two are considered the same key, kind of like, like I said, this one just overwrites this one. So 1, 2, 3 distinct keys, which leads to a length of 3. If we were to take out, say, the model, and then we're to run it again, you would see that we get a different one. We get 2, because we have 1 for brand and 1 for year. Okay. Next one, the dictionary items, like the values that's given after the keys are allowed to be any data type. They can be a string, like here. Sorry, I'll just do this. They can be a string, like Ford. They can be a Boolean, like false. They can be a number, an integer, like 1964. They don't show it here, but they can also be a float. And they can also be even a list, a tuple, or a set. Technically, it's allowed to be another dictionary, but that gets really confusing, and I would advise against it. But yeah, you're basically able to put any type of variable inside of the dictionary. Okay, next we'll go over how to get the type of a dictionary. More specifically, like the type of a value of a variable giving dictionary, because if you make a dictionary and you get the type of it, it's just going to say dict. That's short for dictionary, as like they use it here, like this dict, and it's going to be called a dict in its type. And then lastly, in this section at least, you can make the dict constructor to make a dictionary. So if you want to make a dictionary without doing it like this way, you can also do it a slightly different way, where you use the dict constructor and do like a variable is equal to another value. And you can see exactly how this would be turned into a dictionary. This would be the key. This would be the this would be the value. This would be a key. This is the value. This is the key, and this is the value. And that's how it's shown here. We have the key name is equal to the value John, the key age is equal to the value 36, and the key country is equal to the value Norway. Okay, now we'll talk about accessing dictionary items. Most basic way that you can do it is by using square brackets, like I said. By using square brackets, we're able to, the reason why dictionaries are so different from lists, tuples, and sets is because to access different parts of the dictionary, you're going to want to use the key instead of a number. I guess you can't really get sets using a number, but still. So using a model here as our key, we get the value Mustang. And I already really showed this, so I don't really need to get more into it, but you can like choose a different key to get the value that's associated with it. And yeah, that's how you access an item. There's also a method called get, which does the exact same thing. I can show it. There's not really a good reason why you would use this over the other one, but this does exist if you want to use it at any point. You can just use the dot get and then put in the name of the key afterwards, and it'll give you the same result as if you use square brackets. Oops. Yeah, forward. Okay. Let's say you wanted to get all the keys in the dictionary. You can use the dot keys method, and it'll give you all the keys that are in the dictionary. Like I said, if there are any duplicates as well, it's still going to be considered the same key. So when it gives the list, it's going to give the exact same key. So you can see we only have 3 keys in this. And I mean, it has dict keys here just to show that these are the keys of the dictionary or a dictionary. And then we have brand, model, and year, which are the 3 keys inside of this dictionary. Okay, yeah, so this one is basically adding a new item to the original dictionary. So, yeah, let's say we had a car and we had 3 different keys and key and value pairs to describe the car. So the brand is Ford, model is Mustang, year is 1964. If we get the keys now, you'll see that there's 3 different keys: brand, model, and year. But now we want to add a new key. The new key would be, here in this case, is color, and we want white. So now after doing this, you'll see that when we print the keys again, it'll print it with color as well. So we can add key value pairs by doing it in this specific notation, doing car, and I guess the name of the key is equal to the value that we want to assign to it. We can also get the values of a dictionary. If you remember, it's a key value pair, so it's going to get all of these 3. So like I said, Ford, Mustang, 1964, and those are the 3 that are being printed into as the values of the dictionary. Yeah, and then if we do, oh wait, this is more for changing. We can also change the values of a dictionary, more specifically the values of a dictionary. I don't think it's very easy to change the keys of a dictionary, but to change the value of a specific dictionary, you can do that by just calling it. So car year, saying like, oh, we want to go to the car dictionary and get the year key from that. We want to make this, the value of it, equal to 2020. So now, originally what we had was 1964, and that's shown here. But after we change it, we print it again, and then we see that it becomes 2020 instead of 1964. Okay. Next, this is for a new. I mean, we did this something similar before, but like this is how to add a new key value pair to a dictionary. We just say, I mean, you can see that like calling or like adding and changing a key value pair in the dictionary is the exact same thing. The only difference being that for adding it, you just pretend that it's already there, even if it isn't. So we're just saying car color is equal to red to add it, and even though color isn't there, we can still this still adds the color key to car and puts the value red to it, and you can see it here. We have Ford, Mustang in 1964 as our 3 values, which is here. But after we add color red, we also have red as a value. To get items, items being both the key value pair, not just the keys, not just the values, the actual pair, you'll use this dict.items, and it'll bring all of them up like this. And if you notice, each specific one is in a tuple, which in itself is in a list. So basically, the key value pairs are going to be in a tuple, which all of the different items are going to be in one whole list. Yeah. Brand, Ford, model, Mustang, and then year 1964. I guess we'll go over these two. Changing and adding them also change these. So if you look here, they have 1964, but once we change the year to 2020, it becomes 2020. And then when we add it, you'll see that a new thing appears. Color red also appears because we've added that to our dictionary. We've added a new color red pair to our dictionary. Okay. And the in keyword exists for lists, tuples, and sets as well. But for if we use the in for dictionaries, we're going to be referring to the keys, not the values. So if we were to, so brand, model, and year are all in this dict. But if we were to try and do like Ford, sorry, give it a second. You'll see that nothing runs. And that's because Ford is a value, not a key, and we're looking for keys inside of this dict. Like I said, you can think of it kind of like a treasure chest, where you only know the keys, you don't actually know what's inside the treasure chest, so you don't know the values. So you can't really say that a specific item is inside of the treasure chest without using a key first. But you're able to know the key that exists for the treasure chest. And yeah, it's like model and brand and year. All those are keys that exist in this dict, which is what we're looking for, not the values. So in basically works for keys, not for values. Okay. Changing dictionary items. I really went over this already. Just to change a dictionary item, you just call it like you would a list, but with the keyword instead, or the key instead, and then changing the value. Okay, so update is basically another way of changing the key value pair. And like updating this is basically like this also has to be a dictionary. So if you remember, like with sets, you're able, and if with like sets, you're able to add a specific new items by using the update, but they also have to be of the same like type of variable. So if you're updating a dictionary, you have to have a dictionary as your input, or else it's going to give an error. Here, for example, we're updating it with the year to 2020. And it's, as you can see, it replaces the year 2020 inside of this key. I think it also works for adding, but I'm not too sure. It also works for adding stuff, just like with sets. So if we were to put color red as a dictionary, if we tried to update this dict, it becomes color red. Or it adds color red to the dictionary, I guess. Okay, now for adding dictionary items. For adding dictionary items, again, it's very similar to how you would change it, but you just act as if it's there. By doing this dict color red, we're basically adding it to the dict, and we're able to call this even though it's not in there, because this is how we add something to the dictionary. Again, same thing with update. I just showed it, but you're able to act as if or like you're able to update it with a completely new key value pair, and it'll just add it to the dictionary. Yeah. Um, yeah, I'll go over removing items as well. Okay, so to remove items, there's multiple different ways to do it. First thing you can do. Oh, hold on. Yeah, it's 11:30 now. Actually, I think we'll try and go over this next time, if we have enough time. So I'll just stop right now, and I'll give you guys your homework for tomorrow. Or yeah, tomorrow. Okay. So for your homework, you're going to have to. Oh wait, no. For homework, you're going to have to. Um, you're going to have to do the solo learn, all the way across, like all the way to the end, so that you can get the certificate. And once you get your certificate, it'll be nice if you could like show it in the turn in folder or turn in channel, so that we're able to see that, and congratulate you on getting your certificate. And for those of you who didn't complete questions 1 through 8 in the string exercises, it would be good to if you guys did that for next class. And yeah, that's really that's all the homework that there is to do. If nobody has, oh, yeah. Actually, if you have your certificates, put them in show off, because that would be a good place. I mean, good place to show off your certificate, as the name suggests. So yeah, just once you're done with your certificate, you can put in your homework. You can put it in show off, and show off your new certificate. Yeah. If there's no other questions, I think that's going to be all from us. And yeah, good job, everyone. Bye, everyone.
Bye, guys.